Okay, folks, let's get started with this review. So, this is the review for the final exam. Again, this is the last week of class. You have until Tuesday to take the final exam. And I'll do my best to grade it as soon as they send it to me. Within a day or two, I should have your final exam posted, your final exam grade posted. I have a couple of minor items that has not been graded yet. Last week I went and added the zeros to the items that you have not taken, so that probably drop your score a little bit, but should not be drastic. Remember, some of you have completed the work, and so I've added your adjusted grade there, so or your adjusted score. So let's look at the review. Okay, so as a first example, let me look at it. Number one here, right? Number one is 50% is equivalent to the sum of the number and 17. Now, we need to translate this into a mathematical equation. 50% of a number is equivalent to the sum of the number and 17. So that's fairly simple, right? 50% of a number, so that's 0.5. Let the number be n. So 50% of n is 0.5 n, right? And 17, right? The sum of 17, right, is your equation, right? So the number, 50% of a number, is equivalent to the sum of the number and 17. Oh, I did something wrong here. 50% of a number, forget this here, is equal to the number plus 17. Sorry, I did that wrong. I misunderstood it. But here's your answer, right? Because you're looking at 50% of a number, right? Here's your number n. 50% of it, 0.5 times n, is equal to the number plus 17. Okay, so you should be able, there's a problem very much like this one on the test, so you should be able to do that on the final exam. Let's look at another problem that may be on the final exam here. Graphing, of course, is going to be quite a few graphing on the final exam. Remember, the graph of the absolute value of x is the shape of a V, right? Remember this V here, right? 1, 1 is on the graph. 2, 2, I'm sorry, I have it here. 2, 2. Negative 1, 1. Negative 1, 1 is right here. Negative 2, 2. I don't have this scale properly here. Negative 2, 2. So this is the shape of the graph of the absolute value of x. Now, if you were looking at the absolute value of x minus 1, you can do a little bit of a shifting here. If you take this graph, you move it to the right 1, you would get this one. And this is the graph of the absolute value of x minus 1. If you look at the absolute value of x plus 1, you would move it to the left 1. So you'll get this one. By the same token, if you were given the graph of y is equal to x squared, which is a u, if you remember right, that's a u, right, a parabola. So if you were going to look at x minus 1 to the squared, you would take that u, you would move it to the point 1. You will shift the u to the point 1. Right? If it is plus 1, then you would move the u to the left one. So you'll get this one. Right? Okay, so remember this shifting of graph to help you get the graph that you are looking for. There are some graphs that we call them, I use the term reference graph, right? Reference graph mean, you use, for example, this is, we look at this one already, the absolute value of x, right? This one is x squared, right? Focus a little bit here. This one is x cubed, right? If you remember those. Of course, this is y is equal to x, right? These are reference graphs. So you can shift them to get to be able to sketch other graphs. You can shift them to the right. So this is x to the cube, right? If you are adding or subtracting from the x, remember from the x before you cube it, you are moving left or right. For example, x plus 1 to the cube. This one, you're moving it, it's kind of opposite of what you are really thinking. You're moving it to the left at the point -1, right? As opposed to if you have x minus 1 to the cube, you're moving it to the right to the point 1. Okay, this is a little confusing, so you have to be careful with that. So if I move it here, right, I will get this graph. Okay, so remember, if it's plus 1, remember before you operate on the x, like for example x squared, x cubed or whatever, you're adding 1 to the x. And then you cube it. Remember, what you're doing is to the x, you move it right and left. Okay? As opposed to if you are performing something with the x itself, so cube it, square it, or whatever, and then you add, for example, if you have x squared plus 1, here you are moving up or down. So if this is, remember, x cubed plus 1, I would move it up. So I would draw this, and here's my graph, right? So if you x cubed minus 1, you're cubing the x first, and then you take out a 1, you move it down 1. Okay, remember that. That's very important as you take the final exam. Okay? This is shifting of functions. Okay? Now, notice that how do you find the x and y intercept? This is kind of a review of everything we have looked at, right? So how do you find the x-intercept of a function, of a linear function or non-linear? It doesn't matter. So if y is equal to 3x plus 4, okay, what's the x-intercept or the y-intercept? So to find the x-intercept, remember, x-intercept, you let y be 0. To find the y-intercept, you let x be 0. Okay? To find the x-intercept, you let y equal to 0. To find the y-intercept, you let x be 0. So let's look at this example. if I want to find the y-intercept, x is 0, so make this a 0. So you have 3 times 0 plus 4 is 4. So the the y-intercept is 4. Okay? Remember, to find the y-intercept, you let x equal to 0. To find the x-intercept, you let y equal to 0. Okay? So, here's an example. So if I have 1/2 x plus 1/2 y is equal to 0. Okay, I want to find the x-intercept and the y-intercept. All I need to do is what? You can get rid of the halves if you want to. So, but just like we said earlier, to find the x-intercept, we're going to let y equal to 0. To find the y-intercept, you're going to let x be 0. Okay? So in this example, it's a little confusing because, you'll get 0, 0 no matter what. So that means that the function is going to go through, the line is going to go through the origin, 0, 0. Now, you need another point in order to draw this, because 1 point is not enough. You need at least 2 points. So you can use another point. Let's say x is 2. Right? What is y? So x is 2. So 2 times 2 is 1 plus 1/2 y is equal to 0. Okay? So we have, take out a 1 on this side, take out a 1 on the other side, right? You have 1/2 y is equal to, let's push the note pad there, -1, right? Y is equal to, multiply through by 2 is -2. So we have a second point here. The second point is, remember, we let x equal to 2. When x is equal to 2, y is equal to -2. So here's your second point. So 2, -2, right? -1, -2. Here's your second point. Now you can draw your line, right? You can draw it by, you get a straight edge here, and I don't have one in front of me, but you can do this here, and here's your line. Okay? Shouldn't be too bad here. Okay, let me try to do another one very quickly, and then I have to stop the recording because I have a maximum of 15 minutes that YouTube let me use. So remember, you need to be able to find, if you're given the equation of a line, for example, 5x plus 4y is equal to -6. How do I find the slope of this line? In order to find the slope of this line, I need to write it in the form of y is equal to mx plus b. Okay, you need to be able to write it in the form of y is equal to mx plus b. And how do we do that? All I need to do is solve for y, right? Solving for y. So in the other one, we take out 5x on both sides of the equation. So you have 4y is equal to, take out 5x on both sides, so you have -5x, -6. Okay? What is y? We divide by 4, we divide by 4, we divide by 4. So you have y is equal to -5 over 4x minus 6 over 4, which is 3 over 2, but that's not needed here. All we're looking for is the slope. Now, if you have the slope, you can write the equation of a line, right? So if I'm given the point, let's say I need to find the equation of a line that goes to the point 1 and 6, for example, right? So we know the slope is this. So let's suppose the two lines are parallel. Parallel lines have the same slope. So if this is one slope, This line is going to have the same slope as this one, right? Because they are parallel, right? So you would use the equation y minus y1 is equal to m times x minus x1. At this stage, what you would do, you would put negative 5 over 4 for m, you would put a 1 for x1, and you would put 6 for y sub 1. Okay? So you're going to have y minus 6 is equal to negative 5 over 4 times x minus 1. Okay? That would be the equation of the line. Okay, so let me stop this one so that we don't get into trouble. So I'll stop this one and then